NEC Article 700.12 Emergency Systems, specifically 700.12c line-side taps and load-side taps, states that line-side taps or a load-side tap shall not be permitted when supplying emergency systems. This rule essentially prohibits any taps in the emergency system, irrespective of whether they are on the line side or the load side. Fundamental reasoning behind this regulation is to maintain the integrity and reliability of the emergency power system. Emergency systems are meticulously engineered to provide a dependable power source during situations when the normal power supply is disrupted. Introducing taps, which are essentially points where electrical connections are made to draw power from the existing circuit, introduces potential vulnerabilities that could compromise the system's intended function. These vulnerabilities can manifest in various ways, such as by reducing the overall capacity of the emergency system, introducing potential points of failure, or creating imbalances in the system's electrical load distribution. In the context of an automatic transfer switch, or ATS, which serves as a critical component within the emergency system, tapping on either the line side or the load side would be a direct violation of NEC Article 700.12c. The ATS is specifically designed to automatically switch the electrical supply from the normal source to an alternative emergency source, such as a generator, in the event of a power outage. This ensures that essential equipment and systems, such as life safety devices, critical medical equipment, and emergency lighting, continue to function without interruption. Tapping into the ATS, whether on the line side or the load side, would introduce potential risks that could jeopardize its ability to perform its intended function reliably. Firstly, tapping into the ATS could potentially overload the circuit, especially if the additional load imposed by the tap exceeds the system's capacity. This could lead to the tripping of circuit breakers, the activation of protective devices, or even damage to the ATS itself. Secondly, tapping into the ATS could introduce potential points of failure, such as loose connections, faulty wiring, or damaged components. These failures could disrupt the flow of power to the emergency system, potentially causing it to fail during a critical situation. Thirdly, tapping into the ATS could create imbalances in the system's electrical load distribution. This could lead to uneven loading of the ATS components, potentially causing premature wear and tear or even failure. The NEC prohibition of taps on emergency systems is not merely a suggestion, it is a mandatory requirement that must be strictly adhered to in order to ensure the safety and reliability of these critical systems. Failure to comply with this requirement can have serious consequences, including potential loss of life, property damage, and legal liabilities. To reiterate, an automatic transfer switch is an integral part of the emergency system, and tapping on the load side would constitute a direct violation of NEC Article 700.12c. Therefore, it is strictly prohibited to tap on the load side of the ATS to feed a new panel, regardless of the distance separating the ATS and the new panel. The distance is irrelevant because the rule applies irrespective of the distance. Instead of tapping into the ATS, consider alternative methods of supplying power to the new panel that comply with the NEC regulations. This might involve running a separate feeder from the main electrical service panel or installing a dedicated emergency power source for the new panel. Always consult with a qualified electrical contractor or engineer to ensure that any electrical work is performed in accordance with the NEC and other applicable codes and standards. This will help to ensure the safety and reliability of the electrical system and prevent potential hazards. In summary, NEC Article 700.12c explicitly prohibits tapping on the load side of an automatic transfer switch within an emergency system. This regulation is in place to safeguard the integrity and reliability of the emergency power supply. Any attempt to tap into the ATS would be a direct violation of the code and should be avoided at all costs. Always prioritize safety and compliance with the electrical codes when performing any electrical work. Tapping into an ATS on the load side can lead to several potential problems. One potential problem is overloading the ATS. The ATS is designed to handle a specific amount of current, and if you tap into the load side to feed a new panel, you could overload the ATS. This could cause the ATS to fail, which could leave the building without emergency power. Another potential problem is that the tap could create a fire hazard. If the tap is not properly installed, it could create a loose connection, which could cause a fire. A third potential problem is that the tap could void the warranty on the ATS. Most ATS manufacturers will not warranty their products if they have been modified in any way. For these reasons, it is important to avoid tapping into the load side of an ATS. If you need to feed a new panel, you should run a separate feeder from the main electrical service panel. This will ensure that the ATS is not overloaded and that the tap does not create a fire hazard. It will also protect the warranty on the ATS. Remember to consult with a qualified electrical contractor or engineer to ensure that any electrical work is performed in accordance with the NEC and other applicable codes and standards. This will help to ensure the safety and reliability of the electrical system and prevent potential hazards. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is important to be familiar with the NEC if you are planning to do any electrical work. The NEC is updated every 3 years, so it is important to make sure that you are using the most current version. You can purchase a copy of the NEC from the National Fire Protection Association. You can also find information about the NEC on the NFPA website. The NEC is a complex document, so it is important to get help from a qualified electrical contractor or engineer if you are not sure how to interpret it. A qualified electrical contractor or engineer can help you to ensure that your electrical work is in compliance with the NEC and other applicable codes and standards. They can also help you to avoid potential hazards and ensure the safety and reliability of your electrical system. Emergency systems are designed to provide power to essential loads during a power outage. These loads can include life safety systems such as fire alarms and emergency lighting, as well as critical equipment such as medical equipment and data processing equipment. Emergency systems are typically powered by a generator or a battery system. The NEC has specific requirements for emergency systems to ensure that they are reliable and safe. These requirements include the use of specific types of wiring and equipment, as well as the installation of emergency lighting and signage. Emergency systems must also be tested regularly to ensure that they are functioning properly. The NEC is a living document that is constantly being updated to reflect changes in technology and best practices. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical work is in compliance with the code. You can stay up to date on the latest changes to the NEC by subscribing to the NFPA's newsletter or by attending NEC training courses. A tap is a connection to an existing electrical circuit. Taps can be used to provide power to new loads or to extend the reach of an existing circuit. Taps must be installed in accordance with the NEC to ensure that they are safe and reliable. The NEC has specific requirements for the size and type of wire that can be used for taps, as well as the methods that must be used to connect the tap to the existing circuit. Taps must also be protected by overcurrent protection devices, such as fuses or circuit breakers. Overcurrent protection devices are designed to protect electrical circuits from damage caused by excessive current flow. When the current flow exceeds the rating of the overcurrent protection device, the device will trip, interrupting the flow of current and preventing damage to the circuit. Overcurrent protection devices are an essential part of any electrical system. They help to protect people and property from electrical hazards. The NEC has specific requirements for the type and size of overcurrent protection devices that must be used in different electrical circuits. These requirements are based on the size of the wire in the circuit and the amount of current that the circuit is expected to carry. It is important to select the correct overcurrent protection device for each circuit to ensure that it is properly protected. Electrical codes and standards are in place to protect people and property from electrical hazards. These codes and standards are developed by organizations such as the National Fire Protection Association and the International Electrical Code Council. Electrical codes and standards are constantly being updated to reflect changes in technology and best practices. It is important to be familiar with the electrical codes and standards that apply to your area to ensure that your electrical work is in compliance with the law. A qualified electrical contractor or engineer can help you to understand and comply with the electrical codes and standards that apply to your area. They can also help you to design and install electrical systems that are safe and reliable. Remember to always prioritize safety when working with electricity. Electricity can be dangerous if it is not handled properly. Always follow the safety precautions that are recommended by the NEC and other applicable codes and standards. If you are not sure how to do something safely, ask for help from a qualified electrical contractor or engineer. Always de-energize electrical circuits before working on them. This will help to prevent electrical shock. Use insulated tools when working with electricity. This will help to protect you from electrical shock. Wear safety glasses when working with electricity. This will help to protect your eyes from flying debris. Keep your work area clean and dry. This will help to prevent electrical hazards. Do not work with electricity if you are tired or under the influence of drugs or alcohol. This will impair your judgment and increase your risk of an accident. By following these safety precautions, you can help to prevent electrical hazards and ensure your safety when working with electricity. The information provided is for general guidance only and should not be considered as professional advice. Always consult with a qualified electrical contractor or engineer before performing any electrical work. They can assess your specific situation and provide you with the best advice for your needs.